Hello everyone, in this video we will solve GATE 2020 ME set 2 question number 35. This question is from the topic numerical methods of engineering mathematics, and the question is for the integral 0 to pi by 2 8 plus 4 cos x dx, the absolute percentage error in numerical evaluation with the trapezoidal rule using only the endpoint is. Now let's look at the trapezoidal method briefly. So this trapezoidal rule is used to numerically integrate a function by assuming small trapezoidal areas as our elemental areas and then adding up all those areas. And in this formula given in this green box gives you the trapezoidal rule. So assuming y is some function where y is some function of x given as f of x, and we have elemental length h, then we can use this formula to numerically integrate a function y is equal to f of x. Here y naught is just the value of the function at x naught or at the start of the limit, so at a, and yn is the value of the function at the end of the limit xn or f at b, and this y1, y2 and yn minus 1 are the values of the function in between. Now when only endpoints are used to evaluate the integral using the trapezoidal rule, the formula simplifies. And here in this figure, we can see that if we only have endpoints a and b, which are the limits of this function y, again here y is some function of x given as f of x, then the trapezoidal rule just becomes, so integration of f of x from a to b dx is nothing but h by 2, where h is now given by the difference between the upper and the lower limit. So h is nothing but b minus a times y naught plus yn, where y naught is the value of the function at the start of the limit and yn is the value of the function at the end of the limit. So this just calculates the trapezoidal area inside this curve, and this area actually approximates the area of this function. So now knowing this, let's see how we can solve this question. So we have been given this function f of x, which we can call as y, as 8 plus 4 times cos of x. Now we've been given that we are supposed to integrate f of x from 0 to pi by 2. So our lower limit becomes 0 and our upper limit becomes pi by 2. This then gives the value of h to be pi by 2 minus 0, which is just pi by 2. And since we are only using the endpoints for a single interval, we can use this formula to write f of x dx from 0 to pi by 2 as h by 2 f at a plus f at b. Now let's try to see what f at a is. So f at a will be just the value of the function at 0, which is 8 plus 4 times cos of 0, and we know that cos of 0 is 1, so this becomes 12. And similarly, f at b will be just the value of the function at pi by 2. So this is 8 plus 4 cos of pi by 2, and we know that cos pi by 2 is 0. So f of b simply becomes 8. Now we substitute f of a and f of b in this formula, then we have h as being pi by 2. So this becomes pi by 4 times f of a, which is 12, plus f of b, which is 8. And we can solve this. So this becomes 20 pi by 4 or 5 pi. Now we are asked to calculate the absolute percentage error. So let's see what the actual integration of this function is. So the exact integral will be integration of f of x dx from 0 to pi by 2, which is 0 to pi by 2, 8 plus 4 cos x dx. Now integrating this, we get 8x plus 4 sin x integrated from 0 to pi by 2. Putting the limits, we get 8 pi by 2 plus 4 sin pi by 2 minus 0 and minus 4 sin 0. So this and this term goes away, and then we are left with 4 pi plus 4, since sin pi by 2 is 1. Now, so this is the exact integral. And from the last slide, we have already found that the approximate integral is 5 pi. So the approximate integral is 5 pi. Thus, the absolute percentage error will be given by the magnitude of exact integral minus the approximate integral divided by the exact integral times 100. So this is 4 pi plus 4 minus a 5 pi magnitude divided by 4 pi plus 4 times 100. Now solving this, we get 5.18% or 5.2%. Thus, the answer to this problem is 5.2. And in order to know more about the trapezoidal rule and its derivation, you can follow this NPTEL course video, Trapezoidal Rule and Derivation by Dr. Niket from IIT Madras.